I apologize. I think my video cut off a little short on me last time. I didn't realize the time. So when you finish, you're putting arrows at both ends to show that your graph keeps on going indefinitely. Hopefully you notice that B was 2, which was greater than 0, so the period should shrink. If you notice, it now takes 1 pi unit for our graph to repeat, so that means the period of sine y equals sine 2x is pi. Okay, let's look at our cosine graph. So this time our b is 1/2, right? So 1 over 2. And so 2 pi over 1 over 2, that's the same as 2 pi times 2. So our period should be 4 pi. And I'm realizing that I did not do a very good job of putting a scale on this. So let's just talk a little bit about what this will look like. So again, we want to look at, so instead of having something happen every pi over 2, we want it to happen every pi units. Okay, so it is going to still start up at 1, but it's not going to reach our 0 until pi. And then our next one down will happen at 2 pi, and our next one would happen out at 3 pi. Okay, I'm sorry I did a poor job of drawing this cosine graph, but hopefully you get a good idea. Okay, I did not do a good job with the scale on that, and I apologize for that, but hopefully you can see that our graph is sketched out. Okay, over at 4 pi, way out here on my table somewhere, is where it would finish one full cycle. Okay, the value of c in the equation will cause a horizontal shift. When we're using trig functions, we call a horizontal shift a phase shift. Okay, so this is new vocabulary. You just need to know that a phase shift means a horizontal shift. So you need to clarify, is it a left phase shift or a right phase shift? So the phase shift is defined as the absolute value of negative c. So again, you never say the phase shift is negative pi. You would say the phase shift is pi units left or right. Okay, and you have to determine left or right. And the way we do that is if c is less than 0, the graph will shift right. And if c is greater than 0, the graph will shift left. This is the same as with our regular transformations. So I want to graph y equals sine of x and y equals sine of x minus pi over 2. So my phase shift is going to be the absolute value of c, which is pi over 2. And since my c is negative, I am going to shift right. Okay, so instead of starting at 0, I am starting at pi over 2 units to the right. And in my sine graph, my period did not change at all, right? My b is 1. So I know in one step more, at 1 pi over 2 more, now my next important point is up. Pi over 2 more is center. Pi over 2 more is down. Center. My next one would be up. Going in the other direction, I'm going down, center, and up. Okay, so I fill in my nice sine wave. Okay, I definitely think graphing trig functions is a pencil skill, not a pen skill. So make sure you have a pencil and that you have a good eraser. Okay, our next one. Here we have my C. My phase shift again is going to be pi over 2 because my absolute value of C is pi over 2. But this time it's greater than 0, so I'm shifting left. Okay, so instead of having my start point at 0, I'm starting pi over 2 left. And with cosine, I start up, I go center, down, center, up, center, down. Okay, so I keep my curve using this nice pattern. Okay, and hopefully you can see my arrows at both ends. Okay, hopefully you can see that this has all been shifted pi over 2 units to the left. Okay, I haven't done it, but we will in a couple of other ones. It's important that you label your x-axis and your y-axis, and it's important that every tick mark, okay, every space is worth the same amount. Okay, that's true of all graphing, but I'm going to be a stickler for it on your quizzes and tests. So our last single transformation has to do with D. So if D is going to cause a vertical shift. If D is less than 0, the graph will shift down. If D is greater than 0, the graph will shift up. So again here, our dotted line is y equals sine of x. And this time we're going to shift down 2 units. So I'm going to take every point. I always start at my 0, and I'm going to begin 2 units down. So I take this, I go 2 units down. Here, I'm moving 2 units down. Here, 2 units down. Okay, and then I'm just gonna connect with a nice smooth curve. Okay, and you can see my whole graph has been shifted down 2 units. Similarly, if I have a positive D, all I'm going to do is I'm going to shift all of my points up, in this case by 1 unit. I feel like that one's especially bad. I got off. Okay, and I would go back and erase that. I unfortunately do not have a good eraser. Oh, I do have a nice eraser. I thought I brought one up. Okay, and so you just want to have your nice smooth curve like that, your arrows at both ends. Okay, all of your axes labeled nicely. Okay, so let's talk about if there's more than one transformation. We're going to use the same procedure that we used for graphing transformations using the parent function tables. Okay, so I want to graph y equals sine of x plus pi minus 2. And I want to graph at least 2 periods. Okay, so that means I want to show at least 2 cycles. It does not matter if you are graphing in negative values, positive values. Okay, you just need to make sure that you graph at least 2. Okay, so here are my parent functions, my original x values and my original y values. So I am noticing that my x has now changed to my original x plus pi, which means that x is equal Sorry guys, I screwed that up. So I did it backwards. I apologize, I'm tired. So my original x is now going to be x plus pi, which means that my x is going to be equal to x sub 0 minus pi. Okay, so all I did was solve my top equation for x. So 0 minus pi is negative pi. Pi over 2 minus pi is negative pi over 2. Pi minus pi is 0. 3 pi over 2 minus pi, I need to remember that pi is 2 pi over 2, so 3 pi over 2 minus 2 pi over 2 is going to be pi over 2, and 2 pi minus pi is going to give me pi. In terms of my y, I notice that my y is now equal to my original minus 2. So 0 minus 2 is negative 2. 1 minus 2 is negative 1. 0 minus 2 is negative 2. Negative 1 minus 2 is negative 3. And 0 minus 2 is negative 2. Okay, so if I was looking, I should have probably done this first. If I was looking at this before, my A is 1, so I'm not looking for any type of vertical shrink or stretch. My B is 1, so again, I'm not looking for any horizontal shrink or stretch, and that should also mean that my period should be 2 pi. And if I look from negative pi to pi, the distance there is 2 pi. Okay, so that means my graph will repeat after 2 pi. That means my period is 2 pi. So that's some pretty good evidence that I'm on the right case so far. My C here is pi. Okay, and so I am noticing, because it's a positive pi, that I am looking for a shift, and I'm going to call that a phase shift, okay, instead of a horizontal. So phase shift pi, and because it was positive here, I'm going to the left. Okay, and my D is negative 2, so I am thinking that I am going down 2 units. Okay, so my phase shift, I just said I'm going pi units left. My period, I still said, is 2 pi. My A is 1, so that means my amplitude is the same as my parent graph. It's 1. My vertical shift is I'm going down 2 units. My domain, okay, I'm going to wait to do my domain and range until I've graphed all of my points. So really quickly, I want to think, what would be a good scale for my graph? It looks like I'm going by pi over 2 units here. So I am going to let every 2 units be pi over 2. So this is going to be pi. This is going to be 2 pi. I don't like to write all of my numbers on the graph because I think it gets really tight. But I do like to write some of them. Those got too close. I'm getting nervous about my time, so I apologize for that. This should be 4 pi. And I'm going to do the same on the other end. So this is negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Okay, and then I am going to notice that my lowest y value is negative 3, and my highest is negative 2, so I'm going to make sure I go 1, 2, 3, 4. I'm going to mark this as negative 5. And this is 5. Okay, so now I just need to plot these points. At negative pi, I am at negative 2. At negative pi over 2, I am at negative 1. At 0, I am at negative 2. At pi over 2, I am at negative 3. and at pi I am